NASA launched Voyager 145 years ago, and despite an initial 5-year plan, this flexible spacecraft continues its incredible journey through space. Recently, however, Voyager 1 has returned cryptic and cryptic data, leaving even NASA's top scientists confused and wondering what's next. The Voyager program began in August 1977 with the launch of Voyager 2, designed to explore Jupiter and Saturn before going to Uranus and Neptune. Voyager 1 followed a few days later. Both spacecraft, which are nearly identical and weigh about the same as a small car, were launched during a rare planetary alignment in 1977 that allowed an efficient path of exploration. Despite the second launch, Voyager 1 soon passed its twin and began a mission of extraordinary discovery. Voyager 1 began sending back images of Jupiter in 1978 from a distance of 265 million kilometers. In 1979, it took nearly 4,000 images of Jupiter, including the first slowing of the gas giant's rotation, and discovered Jupiter's rings and 2 new moons. The spacecraft then headed for Saturn, where it found 4 more moons and sent back several images of the ringed planet. After the Saturn mission, NASA steered Voyager 1 to interstellar space, while Voyager 2 continued towards Uranus and Neptune. In 1990, Voyager's interstellar mission began when Voyager 1 came within 6 billion kilometers of the Sun and returned the first family photo of the solar system. After taking more than 67,000 images, NASA's Voyager 1 cameras shut down to save energy. By 1998, at 10.3 billion kilometers from the Sun, Voyager 1 passed Pioneer 10 to become the most distant man-made object from Earth. It officially entered interstellar space in 2012, announced by NASA in 2013. As of 2018, Voyager 1 was 14.5 billion kilometers from the Sun and continued to transmit valuable information about the solar system and beyond. Voyager 1 is now sending back strange, uninterpretable signals that suggest it may not know its exact location. The spacecraft is pre-programmed to alert NASA if it goes missing, but that alert was not triggered. Despite the mixed signals, Voyager 1's antenna appears to be intact and continues to communicate with NASA, although the accuracy of its reports is currently uncertain. This anomaly is particularly curious given the spacecraft's long history of reliable data transmission. The antenna of Voyager 1 is still directed to Earth and continues to receive orders from NASA. This longevity is a testament to the advanced technology of the 1970s. However, NASA suspects that the recent signals may not accurately reflect the state of the spacecraft. Each NASA spacecraft carries a gold-plated disc containing audio and video messages for possible extraterrestrial contact, including sounds from Earth, an hour of Western pop music and greetings from U.S. presidents in 55 languages. As of 2022, NASA scientists have debunked alien intervention theories. Voyager 1's safety protocols are not activated and its antenna is still pointed at Earth. However, the strange signals are unprecedented. According to NASA's Voyager project manager, such anomalies are expected in a spacecraft such as Voyager 1. Now, 23.6 billion kilometers from the Sun, communication is less reliable. Sending messages takes about 2 days each way, which increases the risk of accidents. A spaceship cannot be saved if it has problems. Despite these challenges, NASA hopes that Voyager 1 will overcome its current problems and hopes that it will continue to transmit valuable information from interstellar space. The immense distance of the spacecraft makes any communication, no matter how delayed, extremely valuable to NASA. Data from Voyager 1 will be crucial for future space missions. But his ability to communicate eventually ceases, and the risk of his mission ending abruptly increases over time. So far, Voyager 1 has defied the odds, but how long can it keep sending data? The answer may lie in the universe, and Voyager 1's journey into the unknown fascinates us all. Stay tuned for what might happen next in this remarkable saga. The Voyager mission was not just luck, but a deliberate effort based on human curiosity and a desire to explore the unknown. In the 1960s and 1970s, space exploration was at the forefront of technological progress and national pride. NASA engineers and scientists have worked tirelessly to develop a spacecraft capable of withstanding the harsh environment of space and sending valuable information back to Earth. The design of the Voyager spacecraft was an engineering feat. Each spacecraft was equipped with a series of scientific instruments designed to study the environment of the outer planets and their moons and interstellar space. These devices included imaging systems, magnetometers, plasma detectors, and cosmic ray detectors. Spaceships were also designed with redundant systems to ensure their survival in the harsh conditions of spacepoint. One of the most innovative aspects of the Voyager mission was the use of gravity aids. By carefully planning the spacecraft's trajectory, NASA mission planners were able to use the planet's gravitational fields to increase the spacecraft's speed and change its course without additional fuel. This technology allowed Voyager 1 and Voyager 2 to visit several planets in a single mission, which would have been impossible with conventional propulsion methods. The launch of Voyager 1 and Voyager 2 in 1977 was a historic moment. When spacecraft began their grand tour of the outer planets, they captured the imagination of people around the world. The images and data they send back are revolutionizing our understanding of the solar system. For the first time, humanity was able to see detailed images of the outer planets and their moons, revealing various landscapes and phenomena that had never been seen before. Voyager 1's encounter with Jupiter was particularly groundbreaking. The spacecraft's images of the swirling clouds of the gas giant and the Great Red Spot captivated the public and provided scientists with new insights into the planet's atmosphere. The discovery of volcanic activity on Jupiter's moon Io was one of the most surprising discoveries, challenging existing theories about geological activity on moons. The trip to Saturn brought more surprises. Voyager 1's flyby of Saturn's largest moon, Titan, revealed a thick atmosphere shrouding the surface in mystery. This encounter set the stage for future missions, such as the Cassini-Huygens mission, which would eventually land a probe on the surface of Titan. Voyager 1 also provided detailed images of Saturn's rings, revealing complex structures and dynamic processes that continue to fascinate scientists. After the planetary encounter, Voyager 1 began its long journey to the edge of the solar system. In 1990, as it approached the outskirts of the solar system, the spacecraft took one last set of images and took a family picture of the solar system. Known as the pale blue spot, this iconic image depicts Earth as a tiny, in the vastness of space, a poignant reminder of our place in the universe. Voyager 1's arrival in interstellar space in 2012 was a milestone in human exploration. For the first time, a man-made object has left the heliosphere, the bubble of solar wind surrounding the solar system, and entered interstellar space. This achievement opened a new chapter in the study of the interstellar medium and provided valuable information about the environment beyond the influence of our sun. The mysterious signals now being sent by Voyager 1 have sparked speculation and controversy among scientists. Some believe the signals could be the result of the spacecraft's aging systems, while others wonder if they could point to something deeper. The possibility of encountering phenomena that we cannot yet explain reminds us of the vastness and mystery of the cosmos. Voyager 1's mission has always been to push the limits of human knowledge. As it travels further into interstellar space, it continues to send back data that challenges our understanding of the universe. The longevity of the spacecraft is a testament to the ingenuity and dedication of the engineers and scientists who designed and built it. NASA's efforts to maintain contact with Voyager 1 despite the enormous distance is a remarkable achievement. The spacecraft's signal is incredibly weak when it reaches Earth, requiring the Deep Space Network, a global antenna system, to receive and process the data. This network is a critical part of NASA's ability to communicate with distant spacecraft and continue to explore our solar system and beyond. Voyager 1's gold-plated disk, known as the Golden Record, is one of the most exciting aspects of the mission. Designed to convey the history of our world to extraterrestrials, the disk contains sounds, music, and images that represent the diversity of life and culture on Earth. Adding greetings in 55 languages, nature sounds, and different genres of music reflects the mission's goal of conveying a sense of who we are and what we value as a species. As Voyager 1 continues its journey, the data it will transmit will help us understand the nature of interstellar space and the transition from the heliosphere to the interstellar medium. This information is crucial for future missions to explore beyond our solar system. Understanding the conditions of interstellar space helps us design spacecraft that can survive and operate in this harsh environment. The Voyager mission has inspired generations of scientists, engineers, and space enthusiasts. Its discoveries have expanded our knowledge of the solar system and opened new avenues of research. The success of the mission shows the importance of long-term planning and investment in space exploration. The data collected by Voyager 1 and Voyager 2 will continue to be analyzed and studied in the coming years, providing insights into the behavior of exoplanets and the nature of interstellar space.